Today I'm gonna fight with the magnetic emissions with my new rig. Control it with the servo drivers, and it's a servo motors mounted on the rig. So I'm gonna test this type of tape, which should make the electromagnetic interference less. So we're gonna test that. I have prepared two cables. One cable without a shield. This is a power cable for the servo motor. And I have already made the test, so you cannot see, but it's this is already mounted, the shielded cable. And what I have prepared, I've made a coil 7 turns just to see on the oscilloscope, a small simple oscilloscope, how high the emissions are from the cable. And I'm gonna test it. We have a servo drivers, that's only one connected, so it's only one is sending a signal, and to that one I'm gonna connect first the original one cable without the shield, and after that the shield I've made with that electromagnetic tape. So electromagnetic filter tape, or I don't know how to call it, but there's a shield for tape for shielding the cables, so it's passing current. So yeah, looks good, really thin. The glue on the other side, this glue is not letting the current pass, but we will see. So start the tests. We are starting the test now. Yeah, there's one thing more. So there's a coil, and the ends of the coil is connected to a resistor, 1 kilo ohm resistor. So just to make the reference point, and one side of the coil I need that to connect to ground, so the oscilloscope knows the reference ground from the case, from the server rack. Yeah, we're gonna test it like that. I'm gonna measure the EMI interference level for the cable, which is not connected to any shield. So this is going directly from servo. Yeah, there is a servos, and the cable is connected directly to the servo without any shield. Everything is controlled by a Thanos controller. So I've made 8 turns coil on the cable, which is power the electromotor, the servo motor, and we will see how high the interference are for that. And here we have a level of emissions from the cable. Servo is off. Now servo is, it's actually on. It's making a calibration. Yeah. And this is the level of noise we can see. It's approximately 1, 2, 3, 4, 5, 6, 7 divisions. So there's 200 millivolts per division, so it gives almost 1.5 volt in peak. And yeah, this is the cable without the shielding. So I'm gonna mount the shielding now and see the difference, how it looks like with that shielding cable. Okay, I changed the cable. Right now the cable is a cable with the shield. So you can see the coil here. And we can start the system. Okay, so the conditions are the same. Driver started. Calibration in progress. And now we have the level of noise with that shielded cable, and I put an extra ferrite filter here. So we have a level of noise right now maybe 1.2 division, so that's 200 millivolts comparing to the noise level before. It's 6 times less than it was before, so it looks like it's working. Okay, one more test. Right now I'm testing the same cable without the ferrite filter. So there's a shielded cable, the coil on the shielded cable, system is off. I'm gonna turn on the drivers. Drivers are on, oscilloscope is on. So no ferrite filter, just the tape, which is shielding. This is grounded down there. Maybe we can see. Yes, this is grounded. Calibration in progress. And we're gonna see how many interference or emissions we have now. So the peak, I'm gonna try to move the coil a little bit closer. 200 millivolts. Let's say that's 2 divisions right now, so that's approximately 400 millivolts of noise without that ferrite filter, with the shielded cable. So it looks like this ferrite filter is making noises half